this your x2, this your y1, the beginning, this your y2. Now, from here to here, that's the change in y. It means y2 minus y1, all right? And then this dy, this change in x means your what? Means your x2 minus x1. That is your change in x. So I can write that as m equals to change in y over change in x, and your n equals to what? Equals to y2 minus y1 over x2 minus x1. So this is typically what this is talking about. And you can tell that your x2, how do you get it? It's simply your x plus dx. If this is x1 rather, this your x2 will be x1 plus change in x. Whatever is the difference between, if you add it to x1, that will produce x2. Same thing for the y. But what if you now decide to keep this place fixed and then you drop this one down? This is now the turning point. This line, this point B, is going to fall clockwise and come closer to what? A. So this is like 2 points now. They are very, very close. They are very, very close. Now, what do you notice? They will come so close until they are almost overlapping each other. And as they come closer, this secant drops to become it becomes the tangent to this curve. And then we can say it is no longer changing y over changing x, but it is now what? It is now dy over what? Over dx. That is the implication of what we have just done. Now let me write out this. That is, if this our change in x reduces to an infinitesimal, something, a very small value, then we say it is approximately the gradient of the tangent to the what? To the curve. Now let me show you this. Like I mentioned, this your m is a function of x actually, will now be equals to, which is dy over dx, and this is the limit as this change in x approaches 0 of what? Of dy over dx. That is the implication of that. And if we want to write this, what are we going to write? We will write this as our dy over dx equals to lim as the x approaches 0, and this is our change in y. Is, if I put it in terms of f of x, is another way to describe the variable y. That is a term in terms of s. So we have f x plus change in x minus f of x over change in x. This one simply means, we're talking about f2. It's actually, it means f2 minus f1. Like f2, this is your f2, this place is your f2, f of x2 rather, and this is your f of x1. So f of x2 minus f of x1 is what is describing, because I mentioned to you before that this one is going to be, this is your x1, this is